For decades, software followed a deterministic path. Humans authored the code, and machines executed the steps. We are now moving toward a declarative model. We define a target outcome, and autonomous agents determine the execution path on their own. These agents have moved into active economic roles. They now generate a substantial portion of global internet traffic and independently settle millions of dollars in financial transactions, using stablecoins as their primary rails. This shift has introduced distinct digital entities into the Web3 ecosystem. Recognizable avatars now act as AI co-founders and multi-chain guides, serving as verifiable identifiers within machine-to-machine commerce. But delegating complex workflows to a stochastic machine creates a crisis of reliability. When AI models operate in isolation, they are prone to logic drift and hallucinations, while the marginal cost of the generic software they produce is approaching zero. Delegating real financial assets to an autonomous machine creates a systemic vulnerability that legacy, human-centric infrastructure was never designed to resolve. In a machine-driven landscape, blockchains serving primarily as venues for human retail speculation face a structural dead end. Decentralized ledgers must transition into trust infrastructure. They need to provide a unified layer that offers deterministic logic execution and hardware-verified data for autonomous systems. If an AI agent is going to independently negotiate a trade, the underlying network must be able to mathematically prove the integrity of that agent's logic to any external counterparty before the capital moves. An autonomous transaction begins with the search for information. An agent must gather external market data to form its intent, but it cannot rely on a centralized or manipulatable source to do so. This is the role of the Flare time series oracle. It achieves consensus directly at the network layer, aggregating raw values from 100 independent providers and filtering them into a single weighted median. To maintain accuracy, the system uses synchronized anchor feeds every 90 seconds. These serve as the source of truth, correcting the rapid block latency updates to ensure the data remains reliable during market volatility. Beyond market pricing, machines need to verify external events, like a Bitcoin payment or a specific Web2 API update. This is the domain of the Flare data connector. The connector utilizes a request-commit-reveal process. By requiring signatures from over half the network's validator weight, it cryptographically proves that an external chain event or a web transaction actually occurred. Through these enshrined protocols, the AI agent operates with mathematically backed evidence of external reality before finalizing a financial decision. Once the agent has verified its inputs, it enters the processing phase. It must execute its internal logic and access private keys without the risk of being altered by the host system. This requires verifiable confidential computing, utilizing hardware-isolated environments known as trusted execution environments. As this architecture shows, hardware-enforced enclaves physically isolate the AI's logic and memory. This barrier shields the computation from host operating systems, hypervisors, and cloud administrators. This physical isolation generates a cryptographic attestation, proving to the network that the agent's execution remained tamper-proof and exactly followed its programmed parameters. In the final phase, the agent moves capital across chains. This is where the transaction meets the reality of external settlement. Legacy bridges often rely on centralized custodians, creating single points of failure. The transition to the Agentic era requires a more robust standard: protocol-managed wallets. These wallets operate using a multi-TEE consensus quorum. By requiring simultaneous signature inputs from a mix of Intel, AMD, and NVIDIA hardware, the system ensures that a vulnerability in one vendor silicon cannot compromise the assets. This infrastructure powers the F-asset system, enabling agents to wrap native assets like Xrp and Bitcoin into programmable tokens for use in decentralized finance. Under the F-assets 1.3 architecture, the process is further simplified. Assets are minted directly into a decentralized core vault, a pooled collateral system that no single agent controls. Moving away from individual agent hot wallets increases capital efficiency while providing systemic security for machine-led trades. This completes the trust-as-a-service pipeline. By replacing implicit trust with verifiable data proofs, action proofs, and automated on-chain settlement, we have built a foundation for autonomous commerce. The technology stack is now evolving from individual agents into unified orchestration layers, capable of managing entire autonomous capital systems. Digital entities will inhabit this verified environment, operating across ledgers to navigate complex economic systems on behalf of human users. The long-term value of blockchain technology rests on its role as the verifiable settlement layer for a trillion-dollar autonomous machine economy.